Now let us move to the second question, where we are asked to find out the products of the following reactions. In the first one, you are given a primary amine with a 5-membered ring, and in the second one, you are given a primary amine with a 4-membered ring, and you are asked to find out the corresponding products when these compounds are treated with HNO2. Now, let us see what happens and what this HNO2 actually do. You know that HNO2, the structure is OH and double bond O. Now it gives you OH minus NO plus, which is electrophile. Now in the first case, you have this compound. Here nitrogen has lone pair of electrons, if you observe. Now this is nucleophile and you have got an electrophile. So this nucleophile acts on this electrophile and you are going to get this compound, say NH, H, a positive charge on this nitrogen, and NO, N double bond O. Now this bond leaves away, water takes this, and you are going to get a 5-membered ring with NH and double bond O. Now what happens is, you have got H plus in the medium. This H plus attacks on this oxygen. Here you can see, you may ask me that why can't it attack on this nitrogen? This is because this is in resonance with this bond. So here the negative charge is increased, so H plus attacks on this one. So you are going to get NH plus double bond and OH. Now what happens is, this leaves away since we have water, and you are going to get this compound N double bond and OH. Now here also the same thing happens, where you have got H plus in the medium, and this H plus again attacks on this oxygen. You are going to get this compound N double bond and OH2 plus, and this donates this electrons, and this bond shifts in this direction, and you are going to get this compound, this one, N double triple bond and plus water. So that is, you have started with a primary amine, and primary amine is treated with HNO2, and you have got azo compound, that is N double bond N. Now let us see what happens later. You know that nitrogen is stable, very stable. So this one is good leaving group, since departure of this group is giving to a stable compound. So this group departs away, and you are going to get a positive charge here. Now if you treat it with, you have water in the medium, so you are going to get a substituted product like this one. Now it is very simple, but just see, in the question if you are given this compound, say this one, now what will you do? The same thing happens here. You are going to get a positive charge here. Now here water can attack here, but this is not the major product, because ring expansion can happen here, and you know that 6-membered ring is stable than 5-membered ring. So this is formed, and now water attacks here. You are going to get OH here. So now let's look into the second one. For the second one, you have got this one. If you treat it with HNO2, you are going to get finally a positive charge here. Now you may think that this gives you this compound, but this is actually not, because here ring contraction occurs. It's a classic case for ring contraction. I'll tell you how and why it occurs. Now if this bond breaks in this direction, you're going to get this compound. Now this is very much stable, because it has bent orbital stability. Bent orbital. Remember this from your GOC. That is, this bond is not straight or not as it appears to be, and these bonds are bend shaped. Now because of presence of these bend shaped bond, this can give its electrons to this carbocation, and hereby it increases the stability of it, so it is formed. Now this carbocation, if treated with water, you are going to get an alcohol like this one. Now in the theory in the table, you are told that HNO2 with primary amine reacts completely. So this is how it reacts with HNO2. Now let us try to solve the third question, where we are asked to find the products for the given reaction. In the reaction we have a benzene ring with OH and NH2 parallel to each other, and you have treated that with pH NH2 under two conditions, where in one condition we have pH greater than 7 and in other condition we have pH less than 7. Now to solve this question, you must know the coupling reaction. That is coupling reactions. Now as you can see here, you are using the electrophile as pH NH2+. Now let us see how it is formed. If you remember the previous question, whenever you treat pH NH2 with HNO2, you are going to get pH N2+. The mechanism is taught to you in the previous question. Now this can have the structure like pH N triple bond N plus, or it can have pH N double bond N plus. Now this undergoes coupling reaction. Now let us see what the coupling reaction actually is. First let us consider phenol, where you have OH here. Now this acts as electrophile, and in the presence of basic medium, remember you are using basic medium here, you are going to get a couple product, like it's going to couple at the para product. That is, this is electrophile. This is going to have electrophilic aromatic substitution. It cannot attack on, it can attack on both ortho and para position, but para is mostly preferred, so you are going to get this compound where you have OH here and N double bond N pH. Now this is orange in color. It is P hydroxy, where P indicates para, azobenzene. These reactions are called as Diazo coupling reactions. Now let us see what it is. Or to remember this, you have OH, pH, OH. Now this give you orange, this is orange in color. Now let us see what is the case with PHNH2. You have PHNH2. Here you use acidic medium. pH range is between 5 to 6. Now under this condition, this electrophile where you have pH and double bond N plus will give you same para product where you have NH2 here and N double bond and pH here. This is yellow in color, and remember here you are using acidic medium. Now let's come back to the question where you have first pH greater than 7. This implies it is basic medium, and let's see what happens here. For this compound where you have OH here and you have NH2 here and pH N2 plus, and for pH greater than 7, that is acidic basic medium, you know that in basic medium you are doing coupling with phenol. So you know that for this ortho and para products are favored. Now para to this OH is blocked, so the only thing which is left here is ortho. So you are going to get this compound OH and double bond N pH and NH2 here. Now if you treat this with pH less than 7, that is acidic medium, you know that for this reaction you have either ortho or para products. So the same thing happens here. You will get ortho to NH2, that is OH NH2, and here coupling is occurring at ortho to NH2, double bond and pH. So depending on the pH, the product which you have obtained also differs. So let us go to the next question. After completing the third question, let us move on to the fourth question where we are asked to find out the products in the following reactions. In the first one, you are given a secondary amine and you have treated that with NaNO2 in the presence of HCl. You are told that you have obtained an yellow oily liquid and you are asked to find out what that liquid is. In the second reaction, you are given a tertiary amine with a cyclohexane ring and a methyl group attached to it, and you have treated that with Carus acid. Later you have heated it and you are asked to find out the product of it. First, let us try attempting the first question. As told in the theory, NaNO2 reacts with secondary amine. First, that is NaNO2 in the presence of HCl. NaNO2 in the presence of HCl will give you HNO2 plus NaCl. That is, either you add NaNO2 in the presence of HCl to the mixture or HNO2 to the mixture, the products which are obtained would be the same. So this question would be the same if you have given HNO2 instead of NaNO2 in the presence of HCl. So the question can be asked in that way also. Now let us see what it happens to it. The same thing happens. You have NO here. You are going to get OH minus NO plus. Now you have got this one a nucleophile since it has lone pair, and this electrophile attacks on this. NO plus attacks on this. So you are going to get CH3 N C2H5 H and double bond O and a positive charge on this nitrogen. Now you have got water. It takes up this hydrogen and you are going to get CH3 and C2H5 and double bond O. Now this is what your yellow oily liquid is. This is yellow in color. It is yellow oily liquid. Now this is a reaction of a secondary amine with HNO2. Now at this point I want to discuss one more thing. If you have phenol, let's say, if you treat it with HNO2, then here you will get NO plus. It will undergo electrophilic aromatic substitution. You know that it attacks at its para position predominantly. So you are going to get finally a product like this one, where at para position you have NO. Now here you have para tautomerism. I'll tell you what it is. Para tautomerism. That is, this bond shifts here, this bond shifts here, this bond here, and this lone pair is donated. That is, this oxygen is donating the lone pair to this bond, and this bond is being shifted here, and this bond here, and finally it here, and you are going to get a compound like this one. Finally, and OH here, double bond O here. This is called as para tautomerism. Now let us try attempting the next question. Now let us try attempting this interesting looking question where you are asked to find out P, Q, X, Y, Z for a given sequence of reactions, where in the first one you have treated this compound which is 2-butanamine with excess of methyl iodide. You have said that you are going to get X, and you have then treated this with AgOH, and you have told that you are getting Y and Z, where Z is an yellow precipitate, and later you have treated this Y at high temperature and you are going to get P and Q. You are asked to find out what are these things. First let us try attempting the first part, where you have CCCCNH2 with excess methyl iodide. Now if you remember from the theory, whenever you got primary amine, say RNH2, if it is treated this with CH3X, you are going to get substitution here R and CH3H. If you treat it with one more CH3X, you are going to get R and CH3CH3. Now if you treat it with one more CH3X, you are going to get a quaternary ammonium salt, where you have CH3, 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 positive charge on nitrogen, and X minus. It is quaternary ammonium salt. This part you are taught in your theory. Now the same is the case with this question. If you carefully observe, here you are adding methyl groups, so it is called as exhaustive methylation. Exhaustive methylation. Now for our question, our X is I So the compound which you are going to get is R N CH3 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 plus I minus, and replacing R with this group you have, that is C C C C N CH3 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 plus on nitrogen I minus. Till here you are done with the first part. Now let's try attempting the second part of the question, where you have subsequently treated this one where you have got your X with AgOH, that is Ag plus OH minus. Now it's just a reaction between a cations and an anion. You are going to get compound like C C C C N CH3 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 positive charge here, OH minus plus AgI. This is yellow precipitate. So in the question you are given that you are getting Y and Z, where Z is yellow precipitate. So this is your Y and this is your Z. So here we are done with two parts of the question. Now let's try attempting the third part, where you have treated this with at high temperature. Now higher temperature will show you, just like the previous question, elimination, because at high temperature elimination favors because it involves cleavage of bonds. Now if you carefully observe, you have got this group which is the leaving group, and one thing which you need to remember is it is poor leaving group. Now you will be taught in your alkyl halide chapter and also in your alkene chapter, in the presence of a poor leaving group, the intermediate possesses a partial carbanion character. So that is, you have two hydrogens which of our interest, this one and this one. Either this hydrogen can depart or this hydrogen can depart, because you are considering only alpha hydrogens, that is, this is alpha 1, this is alpha. Because one of these hydrogen has to eliminate and this will depart, you will get a double bond either here or here. Now you have to see which double bond you are going to get. Now you are told that you are going to get a partial carbanion character. If you carefully observe, carbanion here and in the first case, and in next case you are going to have carbanion on this carbon. This is secondary and this is primary. You know that these are electron donating groups and it increases electron density. So it is destabilizing this one. Even this is also destabilized, but it is lesser than this one. That is, comparatively it is more stable. So this alpha hydrogen is eliminated rather than this one. This is eliminated and this won't be eliminated. That is, you are going to get a compound, or finally I'll write it here, C C C double bond C. So carefully observe that this part is very important. As you can see here, you are going to have a partial carbanion character. Now plus one more product you are obtaining, that is N CH3 CH3 CH3, and you also have water, and that is leaved. You also have water, don't worry. Now here in this question you are careful to observe one thing. So a lot of things you have to observe here, not just one thing. First one is this one. You are given excess here. Excess of alkyl iodide should tell you that with primary amine you are going to get a quaternary ammonium salt. So that is we are told in a theory to remember it carefully. So you are done with the first part, and in the second part the clue which you have got is yellow precipitate. Yellow precipitate will remind you of AgI, which is yellow in color. So replacement of this I minus with OH takes place, so you are going to get this one. And next important thing is this group is poor leaving group, and next one is you are going to get a partial carbanion character. And the importance of high temperature here shows you that you are going to get elimination product. So you have the elimination product with you, and you have this one, and also water. But for questions we generally do not consider water because it's a common one mostly. And this one you have also read, where secondary carbanion is less stable than a primary carbanion. And finally you got your product. So let us move to the next question.